Hi there, welcome back to my channel. Let's solve this interesting 3D geometry problem. We have a cylinder of radius r, which is inscribed inside a cone with base radius 4r. How many times larger is the volume of the region between the cone and the cylinder than the volume of the cylinder? In fact, we are going to find this ratio. Volume of cone minus volume of cylinder over volume of cylinder. You know that for finding the volume of cone and cylinder, we need the radius and the height of them. The radius of this cylinder is r and the radius of the cone is 4r. And now I'm going to draw the height of the cylinder, the height of the cone, which is perpendicular to the base of cylinder and cone. And now I'm going to call these points A, O, B, O prime, and C. If we cut this cone through its height, in fact, the cross section is going to be this isosceles triangle. I'm going to use this section of this isosceles triangle. I'm going to use the similarity of these two triangles. In fact, we have two triangles, the small one AOB and triangle AO prime C. These two triangles are similar. The reason is that both triangles share same vertex angle and both have right angles. Okay, so according to fact angle, these two triangles are similar. And I'm going to use this similarity to write the ratio of corresponding sides. Before that, I'm going to call the height of this small triangle H and the height of the large triangle, which is here, big H. Okay, and now I'm going to write the ratio of corresponding sides. The first one is AO, which is H, and the height of the large triangle or corresponding side is big H. And then this leg is OB, which is R, over corresponding side is O prime C, which is 4R. These two R's are cancel out, so I found that big H is 4 times small h. Okay, so h is 4 small h. This part is h. This one is 4h. So by subtracting h from 4h, I figure out that this part, O prime, is 3h. Okay, so this part is 3h, which is the height of the cylinder. And now let's plug in all these values in this ratio. Okay, for finding the volume of cone, let me write this. The volume of any cone is 1/3 pi r squared h, when h is the height and r is the radius. Okay, for cone we have 1/3 pi, r for cone is 4r squared times h, and h is 4h, minus, and the volume of cylinder is pi r squared h. R is the radius of the base and h is the height of the cylinder. For this green cylinder, we have pi The radius is exactly r, and h is 3h over, and the volume of cylinder is pi r squared times 3h. And now I'm gonna simplify this fraction. Okay, 4 squared is 16. 16 times 4 is 64 over 3 pi r squared h minus 3 pi r squared over h, and the same for the denominator, 3 pi r squared h. And you can see that this expression is in terms of r and h. Okay, I'm gonna factor out pi r squared h, and the remaining part is 64 over 3 minus 3 over 3 pi r squared over h. I'm gonna cancel out pi r squared h by this one. Okay, so we just need to simplify 64 third minus third over 3. Okay, so let's use denominator 1, and the common denominator is 3. 64 minus 9 over 3 over 1. And 64 minus 1 is 55 over 3 over 3. So 55 over 9 is the final answer of this question. In fact, the volume of region between cone and cylinder is 55 over 9 times larger than the volume of the cylinder. Okay, this is the end of this video. I hope you enjoyed it. And please don't forget to subscribe to my channel and support me. See you in the next video. Bye for now.